Hello! Last time we gave our player character a proper class with state and behavior. But as the game grows, new characters keep showing up. Guards, quest givers, merchants, etc. And they all share a lot with the player. Same coordinates, same size, same drawing logic. Copy-pasting code between classes is a road to madness. So today we are going to fix it with one of the core pillars of object-oriented programming, inheritance. Let's dive in. First of all, let's define NPC class. And as we did with the player objects, let's refactor existing code to use NPC class. Okay, everything is working, but let's take a closer look at the player and NPC classes. NPC and player have a lot in common. Like, all of them are probably humans, all of them drawn onto the screen, and they all have screen coordinates and size. So, why do we have separate class for NPC and do not reuse player class? Yes, they have a lot in common, but they still behave differently. So, in one hand we want to unify coordinates and drawing logic because it will be the same for player and the NPC. In other hand, we want them to behave differently. What can we do? We can use another class. Let's call this class GameObject. GameObject will have coordinates, size, and can be rendered to the screen. But how it will solve the problem? And the answer is inheritance. Like child inherits eye and hair color from its parents, class can inherit properties and methods from the base class. To inherit X and Y properties from the GameObject class, both NPC and player classes should specify GameObject as the base class on the class definition. Now we can say that player and NPC are childs of the GameObject class. Also, we can remove X and Y properties definition from these classes since they will be inherited from the parent class. Let's try to run and test the game. And it didn't work. But why? We moved size property to the base class, which means it should be available for child classes. And this is right. But we initialize this property in the parent init function, which is called class constructor, by the way. As you may remember, this method is called every time object of the class is created. But we never create GameObject class object directly. We only create child class object and they have their own constructors. So, we have to call parent constructor inside child constructor somehow. To call any parent method or property, we will use super function. Also, we can remove x and y initialization in the child classes, since them will be initialized in the game object class constructor. Okay, let's test it and see if we fixed all the issues. Cool. Remember, I promised you to finally replace NPC placeholders with the actual sprites. Let's do it. I have 3 sprites prepared for the player character and NPC in the game assets folder. If you don't have these images, you can download them from the game repository. Links will be in the video description. So, plan is to add sprite image pass property to the game object and implement draw method to draw the sprite. Here we will use Pygame image model to load the image and create the sprite. Now we have to render the sprite into the screen. Let's first check how do we render player character right now. Screen is a Pygame object that represents game window. And to render image we call screen bleed method, specifying sprite and coordinates tuple. So let's move this logic into game object class. As you can see, my editor shows a row that argument is missing for parameter image. Indeed, we change parent constructor method arguments, but do not update the child classes. So let's update child classes constructors and provide proper image path to the game object constructor. In NPC class, we will use guard asset if NPC role is guard and quest giver otherwise. And all it's left is to replace current drawing logic with object method call. This is the power of inheritance in action. Player and NPC objects don't have draw method, but they inherit from the parent class. But you may disagree with me. Before that, we not only render NPC, but also its name. Yes, we generalize our draw logic into a single method, and now we can draw name only for the NPC. Or do we? We always can override parent class method in the child class to make some class specific logic. Let's actually do it. To override parent method, we will implement NPC method with the same name as the parent method. Let's test it. As you can see, now NPC name rendered. Just to wrap it all up. Inheritance allows class to inherit some properties and methods from the parent class. but child class could also override parent class properties and method if it needs to. Okay, that's it for today. In the next video we will finish refactoring NPC class using last object-oriented programming pillar polymorphism. If you have any question, leave them in the comments down below, like the video, subscribe to the channel, and see you next time. Ciao!